This is my last lab for Physics 1. So we're supposed to choose whatever we wanted to do. And so I wanted to choose the conservation of momentum in a collision of 2/4 and a dime. So the problem was find whether or not the conservation of momentum was valid in the collision within the system, which was 2/4 and a dime. And the main result was it appeared that the momentum was not conserved in the system. Okay, so I'm going to go to my tracker video. I put the axis on the quarter as it was in motion, and then I tracked it, and then I also tracked the dime when it started moving. And I used this little marker here to kind of calibrate the scale of the quarter for the whole thing. So here's my video. Okay. So mass A is the quarter. Here's its values and its graph. Mass B is the dime. Here's its values and its graph. And the x values are in meters. So I tried modeling this in Python, and all I basically did was the momentum principle. Ball position equals ball position plus ball velocity times delta t. And I did that for both the first ball, for the first ball and the second ball, and the balls are supposed to be the quarter and the dime, respectively. And the amount of time is 0.233 seconds, because that's what it was for my tracker video right here. And sorry about that. And the change of time was 0.0033. And so here is my model. So as the quarter moved, and then it hit the dime, and then here this when the dime moves. And then there's the graph. Okay, and here are the results, and this is the final position of both the quarter and the dime. Okay. So here are the calculations I used. Velocity of the quarter initially, which was for the first delta t, I just did how far it traveled, which is 0.45 meters over time, which was 0.033 seconds, and I got this value. Then to find the velocity of the dime, I used the conservation of momentum. Momentum q is equal to momentum d, all within the same system. And I solved for the velocity of the dime, which was 3.405 meters per second. So the experiment results were the quarter ended up at 0.048 meters away. The dime was 0.26 meters. In the model, the quarter distance was 0.049 and the dime was 0.724 meters, which makes it appear that the conservation of momentum was not in fact valid. So here's my conclusion. I believe that the collision was inelastic. So what I'm trying to say is, like, there was a change of internal energy which factored in, which gave the dime less velocity than what should have been expected, which should have been 3.4045 meters per second. Because of this change of internal energy, we did not get this velocity. So because of that, conservation of momentum is still valid. So I want to say thank you for watching my last lab, and yep, thanks for watching, I guess.